Why, hello there, and welcome back to a Game Dev Engineer Super Duper Study Sheet. Today, we join us again at 4 a.m. and today we're talking about C++ miscellaneous stuff. So the first one here is the placement new operator, which I learned recently when I was working at the God of War studio. A very, very intelligent engineer taught this to me, Victor Cepeda. And basically, it's an important operation because it allows you to place a given piece of memory in the exact spot that you want it if you already have the heap section allocated. So that's wonderful. Also, if you want, it doesn't need to be on the heap, right? If you want to just grab a page of memory and manipulate it on your own, then the placement new operator allows you to do that, where you can say exactly where in memory you want to put it. And I'm pretty sure you could pass it a pointer that actually points to the stack, so I don't see an issue there. Another thing that is commonly asked is, how do you delete memory when you do a new versus a malloc versus a new with brackets, right? And so you got to understand that the C style is malloc and free. The C++ allocations are new and delete. And really, in general, you shouldn't be using this stuff when you can. You want to use smart pointers instead of... you want to use smart pointers where they manage the object's lifetime. But, when you have to use an explicit star like this, and these are the options, and you got to understand the pairing between the two. Okay, big O complexities. I haven't... Well, I pretty often they'll ask you to, code something, and then they'll say, oh, what's the big O complexity of this algorithm? And so in that case, you need to understand how to do that and then the relationships between them. Streams versus branches. I mean, I don't know if I've really... I have gotten questions kind of like this, where basically they ask you, because streams are how they work specifically in a system like Perforce, whereas branches are how they work in a system like Git. So you need to be familiar with whatever the whatever the version control system is that the studio you're interviewing for implements. Oh my gosh, this is the really important section right here. I have failed interviews because I didn't understand this section. File input and output. It is so common that a AAA studio is going to send you a big blob of data that's written in some sort of binary nonsense, and they're like, hey, parse this shit for us into some struct and then, print it out or something. I've gotten that interview many times, particularly for the take-home tests, where they might give you a take-home test before they give you the on-site because, they don't want to spend a flight ticket on any schmo. So basically, this is how you want to do that. You're going to want to, include the F stream, create an input stream where you've got a reference to the text, right? This is the path to a.raw, which is, some binary file. And in particular, you need to pass in this thing here, which says that it's a binary file. Holy cow, you don't know how badly I've been burned by that. Because if you don't say specifically that it's a binary file, the input stream reader is going to do optimizations around new line characters in ways that are going to totally fuck with it because it's binary data. New lines, don't mean shit for that. So you need to definitely pass that in as a parameter, which I didn't, and that's why I failed the interview. So if you could sense why I'm a little bit annoyed, that's exactly why. Okay, what else is going on here? So then, num shapes is 0, and then what I'm reading is the first... what is this? I'm reading the first uint. So basically I'm reading bits of equal to the size of uint32, and I am... What am I doing there? And I'm pasting them into num shapes. Okay, pretty cool. So that's the input system, and it's really important to understand everything that's going on in this little box here. Very important. Okay, so let's talk about smart pointers. There's a whole bunch, isn't there? Unique, shared, weak. The definitions are right there. Not much to say, but you got to know them. References. Okay, very common, right? They're going to say, what's the difference between a reference and a pointer? And then you're going to say, oh, references can't be reassigned. They can't be known. They don't have their own address, whereas a pointer is essentially a new variable. And you also have the power of doing something that's the pointer plus plus, which is pretty common, especially when you're reading, huge... binary files. That's pretty common for you to do plus plus operations. Okay, what else is going on here? So they might ask you this. This is a pretty common question as well, where they'll say something like, hey, what are classes that are automatically generated by a compiler? I've gotten that on a bunch of interviews. you know, and even if you don't get it right, this is just something that's pretty important to know. And so the classes that are generated are the default constructor, the copy constructor, copy assignment operator, and the copy assignment operator. I just wrote that twice. This looks like the destructor. Why does it say copy assignment operator? It should be destructor. Destructor. Okay, and then there's two other things for C++ for 11 plus, which you're probably using, which is the move constructor and the move assignment operator. Oh, moves? What is that? Oh my God, L values, R values? I didn't even learn that in school. I paid, well, thank God, I actually didn't have to pay. I was very fortunate. My parents paid for me to go to education in a university. I went to an expensive school, Stanford. It cost maybe $250,000 fucking dollars. And guess what? I didn't even learn half of the shit I needed to know, including the difference between an L value and an R value. So if you don't know that, look it up because it's relevant. So this is a really great example of just understanding the differences here. This guy Bo Kian or Xian, man, he's good. He's really good. So just understanding the move semantics. Just watch this video, his other video on R value reference perfect forwarding, and I think you'll be all set. And that's basically what is the move constructor, move assignment operator. Great stuff coming in C++ 11. It's here, and it's gonna stay here because people love it. Okay, so when are they not auto-generated, right? So you want to understand when a destructor is not going to happen, and I don't know if we've addressed it. We'll address it later, but there's one of the most common questions, which we'll cover in the next video, is the virtual destructors, because that is the cause of many headaches. So we'll talk about that in just a sec. So when are these different methods going to not be generated automatically by the compiler? Well, of course, if you implement your own, they're not going to overwrite your implementation. You can also explicitly prevent it, which is something like this, where you can say equals delete. The syntax here looks very similar to a pure virtual method where you've got equals 0, which is down here. But instead you do equals delete, which tells the compiler, linker, whatever it is to don't make this. And then again, when a compiler can't auto-generate it, then it won't. So for example, here's an example I have here where you've got a dog and a pet. So obviously, the pet is the parent class or the superclass, and then the dog is the subclass or it extends the pet, or it is a pet, right? So dog is a pet, and pet has no copy constructor. So if pet has no copy constructor, then dog is not going to automatically have a copy constructor because it's not going to know how to deal with pet's members during the copy. And because it extends that class, it's going to have members that it's just going to not know how to copy. And so because of that situation, it's not going to automatically be implemented because the compiler can't infer what you want to do there. Okay, two other things, hash tables and arrays. I was working with this guy, Sweeney, and I remember he said to me, man, arrays are great. You could use them for pretty much anything. And he was right. And I haven't forgotten that since. Arrays are awesome. Like, they're so great. Like, the benefits of having memory contiguously set up is just amazing. It really is. And you'll see that soon enough if you don't believe me already. But arrays, the big one is access to an array element is trivially fast. You want to get the 0th element, array, open bracket, 0, close bracket, boom, you're done. Arrays are good when there's a semantic order, so yeah, that makes sense. Arrays are also good as the default, right? If there isn't a semantic order, you just got a blob of data. Arrays are a great thing to use there because they don't have a huge overhead. And then second, first thing, great. So hash tables can be an array on the back end, not almost always, I think. But there's probably other ways to do it. Hashing, we talked about that earlier, but it helps during the search process, so you can make. So if you don't know where things are, then searching through it, that's when you're going to want to implement something like a hash. And then, so as I mentioned before, there's two ways to resolve collisions. You can, penetration test for looking for openings. You keep going forward. Or what you could do is you could do a linked list at each hash value. Okay, cool. So we're about to talk about dex. This is an interview question I failed, and it made me very sad. But we're going to wrap this video up here. I'll meet you in the next video. If you're in the playlist, you don't got to go anywhere. But before the next video starts, please slap that like button. And let me know if I missed anything in the comment section. I'd be happy to help you.